All right. Now, in the last few minutes, I'd like to talk about nilearn because this is medical imaging, and I'd like to see what we can learn from nilearn. So, our goal, my personal goal with nilearn is to make fancy data processing easier, to commoditize fancy publications. So, for instance, there is this publication by this Japanese group a while ago, almost 10 years ago, that showed that they can do reconstruction of the visual field from the human brain activity. So that's a decoding problem, and our goal is to make it so easy that it becomes boring. And so you now have an example, because these people shared the data, you now have an example that you can run that basically reproduces the gist of their paper. It's not the exact same method, because there are ways of doing it simpler, but it's there, you can run it, it's easy. So the challenges that we have to solve for this goal is the first one is to get data for people to be able to try things out. And that's a big problem for us, because it's not a problem that we can solve. We need to basically beg people to share interesting data. And there are things in Scikit Learn that we can't develop because we can't show that they work on open data. That's a bit of a curse of the medical imaging field, is that medical imaging field is often not interested in sharing data. Then the second thing is that we need to message the data to go from images to something that we can stick in a Scikit Learn estimator, and that is quite often very simple signal processing, but it turns out it's very important. Then an important challenge is documentation. I spent 1/3 of this talk explaining you what are the problems of machine learning in medical imaging, because it's important to understand them well. And finally, we find that we absolutely need to have good output and good visualization, because this is how people are able to understand what they're doing and whether the thing works or not. Okay, so I could run an example, but I don't have time, so basically I'm going to walk you through this. The idea is that our examples fetch the data from internet, then quite often what they'll do is that they'll use what we call a masker object that goes from 3D or 4D images to 2D feature matrix by transforming the data, and there are a bunch of different options that you can pass to the masker. And then once the data is transformed, we just use Scikit Learn. That's easy. And once we're done, we just plot things or save them. Now there's a bit more to it, and I won't cover this, but we've also included specific learners that are very useful for the kind of data that you have in brain imaging. So typically highly correlated, low SNR spatial maps. So for instance, that's a total variation penalty here. It learns to predict while segmenting maps. And this is, for instance, so these are very simple examples. You can run them. And this is something that will extract brain regions using dictionary learning from REST data. And these, by the way, are the examples of the output of the examples. So this runs. And here you have a connectome that's run and extracted. Okay, so to conclude, maybe I should say all these examples, by the way, they run on the cloud every time we do a commit. So we're testing that our stuff works on real imaging data, always, always, always.